Hello, can you hear me? Hello, hi. Let me know if you can hear me. Maybe the the voice is a bit low. Let me see if I can raise this up a little bit. Hello. Hello. Uh. I wonder if you can hear my voice. Let me know if you could. I'm wondering if I have to raise the master volume of this one. Like, how's this? Okay, well, I think this is the maximum that I can go. Alright. I'll just begin. Let me just check if I can hear it myself. Okay. Think. Hello, hello, hello. Okay, well, let's just go with this. Hopefully this gonna work. Okay, so this is a tutorial live stream with Houdini. It's a weekly live stream for Houdini that I've been doing. And this is Junichiro Horikawa, and today I'm going to try to implement using Copernicus to implement the dithering, order dithering effect, which is pretty classy algorithm in order to create a dithered effect. And what I wanted to do today is to use OpenCL to create this dithered effect from the captured image. It could also be from the image or image from like external file, or could also be from a video file. What's good about the new Copernicus is that you can just import the video file as it is and just use it for image processing, which is pretty easy, pretty handy. I think I should connect it here, here. So what I'm planning to do is to show the process that I have made here in order for you to test later. Okay, I think it's pretty versatile. I mean, it's pretty, if you are into this kind of dithering 2D effect, maybe you might like it. If I have time and if you are interested, I can also show you some other visual effect on the image, such as like the glitchy effect on the image, or I could also show you how you can use create some subpixel like image. Subpixel means you use 3 colors, all red, green, and blue, and combine these colors in different brightness to create one color, which is the method used in most of the displays, digital displays. And I can show you how you can mimic this kind of effect using Houdini if you're interested. So if you look close into the image, the pixel looks like these. You have 3 colors, and by from each pixels you convert it into 3 colors, R, G, and B, with different brightness. And if you combine them together at some resolution, it seems to looks like mixed color. Yeah, that's how digital display works. So that's another things maybe I can try today. Okay. Overall, I was just playing out with the OpenCL, see what I can do with it. Okay. So the reason why I chose these topics is because this is pretty essential image processing method. So it's pretty easy to implement as well. Alright, so that's what I'm trying to do. Let's create this from scratch, as always. So today I'm not really going to do a lot of Vex works, which I used to, but mostly it's going to be done on OpenCL. Okay. So let's save this to today's folder. Okay, I'm gonna make the background maybe as it is. Right. Okay, so first thing first, let's check the algorithm for the dithering. If you search for ordered dithering on Wikipedia, there's a explanation how you can implement this dither effect. And the most famous dithering effect is called ordered dithering, which uses this threshold map to convert each pixels with these map, these threshold maps indicates the replacement threshold, threshold for each pixels, how you would want to replace this specific pixels in either black or white, which you can see it here. So based on those threshold map, you place this map onto a pixels and compare each number with the current grayscale value. And if the value is, if the threshold map value is smaller than the current grayscale map, then you're going to make the map white. In other case, make it black. So if you choose 4x4 threshold map matrix, you have you're going to going to crop each pixels, each images into 4x4 pixels and compare these pixels with these map and see which pixels should be replaced with black, which pixels should be replaced with white if it's a binary dithering. And as a result, you get these kind of pattern, the dithered pattern. In this case, it's using 4x4 ordered dithering map. Right? So that's how it works, and it's pretty easy. The only thing you need to do is to create these maps somehow, and this is the algorithm how you can create this threshold map, which is called as Bayer matrix. So the most of the matrix, most of the algorithm goes to how you can implement this one here. Now when it goes above like 4x4 matrix, you can't really use it on either OpenCL or Vex or Python. If you use NumPy, maybe you could, but OpenCL doesn't support big matrix values, so what I'm gonna do is to create a long single array and use that instead of a matrix structures in order to have these values be used in OpenCL in Copernicus. Okay, so that's my plan, and let's see how we can do this. Now this one doesn't really need to be done in OpenCL. I think I can just do it outside the OpenCL, maybe using Vex or maybe using Python instead. Now this here, if you look at this one, you see the calculation is more of a recursion, because if you enter 1 to n, you're going to have another mn right here, which you are going to calculate another matrix again and again. So Vex doesn't allow you to do a recursive calculation, so maybe using Python might make sense in this case. So let's try doing this. You could still do this in Vex. If you just need to know how many times you need to loop. Maybe I'll just do it in Vex, because it might be faster. Okay, so I am going to create a geometry node. I'm going to create a attribute wrangle. Let's call this detail. I'm gonna call this to create a Bayer matrix. Okay. Now initially you need some parameters in order to create a matrix. That is the size of the matrix. As you can see, this, if you choose 2, 4, 6, you have different sizes. In this case, what I'm gonna do is to, well, since this is a multiplication of power of 2. So this is multiplicated by 2 by 2 is by 4 by 4 by 8 by 8. Okay, so initially I'm going to create a value called matnum. Let's say this value indicates the number going from 2, 4, 6, which in this case I'm just gonna call it, I'm just gonna give it 1, 2, 3 for each matrix. So this one's going to be the matnum equals to 1, matnum is equal to 2, matnum is equal to 3. So somehow I need to convert this value matnum to these numbers, the number of width and number of columns and number of rows. Okay. So what I could do here, let's call this, let's call the lengths and the column and the rows as calls, and try to use a function called power with this matnum. Now as a result, let's check what we got as a result. So if the matnum is equal to 1, you get 2. If the matnum is equal to 2, you get 4. If it's 3, it's 8. So which is the same column size for these matrices. Okay. So we have the same row numbers, so I'm just gonna create that same variable here. Okay, and create these attributes. The characteristic of this threshold map is that it's a square matrix, but later maybe I can show you how you can create the rectangular matrix be used in dithering as well, which as a result you could create some interesting effect rather than using the default, the ordinary maps, which is again an interesting thing. Okay, now that I got the rows and columns, what I need to do is to actually create these numbers. Okay, so let's do that. And in order to do that, I think the first thing I need to do is to let me see. Create. Let's see what's the easiest way to do this. Okay, I'm just going to create a loop. Since Vex doesn't allow you to do a allow you to do recursive calculations, what I'm going to do is to just loop through all the pixels, all the items in the matrix, and then calculate for each numbers based on these calculations. Okay, so let's go with the small numbers. So in this case, n is equal to 1 for these calculations, so it's pretty simple. If the n is equal to 1, m1 doesn't really exist here, so you just need to calculate these values. If n is equal to 2, then you're going to have you're going to be calculating for each squares individually. Okay, using these calculations recursively. Okay, so let's see if we could do that. Okay, so I'm gonna go with the simple examples when the num is equal to 1. So for int calls and for rows Now, previously I made this function in Python. In examples, I don't have the functions in Vex, so I have to kind of try out how this is gonna work. Okay, so let's first use these to do the calculations. Okay, so actually, it might make sense to have this as a function so that I can reuse it over and over again when it comes to recursive calculations. So I'm going to create a function here. So maybe I can make it as an array, or let's say, or 2x2 matrix. Shall we try with the 2x2 matrix? Or not sure if that's easier way. Well, I'll just try. Okay, and the function name I'll just gonna call m. Okay, now just gonna assume that the n is equal to 1 in this case. So if n is equal to 1, I'm gonna create a set function, and for each values I'm gonna say okay, I have another set here. Okay, so 2 power of 2. Wait a sec. Maybe this is not really a efficient way to do. Let me think. Okay, well, I realized I do still need to use a recursive method, so forget about using Vex after all. Sorry. Hi, Raphael. Perhaps write a function that converts a list of floats into n-dimension matrix. Yeah, that might be the way. Okay, well, I think it's easier to do in Python, so I'll just go with the Python. Sorry for that. Okay, so I'll just give a matnum as it is in the attribute wrangle. After that, I am going to use a Python function, Python node, to create a actual Bayer matrix here. I'm just gonna call it init. Okay. So here I am going to first of all import the math module, and I'm gonna define a dither or threshold map function here, and based on these calculation I'm going to say n as an input, and also I'm not going to create a function which gives all the results, but just going to give each element. I'm just going to create a function which gives in each element as a result. Okay, so which means I need to give column and row number. Okay, and what I really mean by that, let me try to draw it out. So if I have two by two matrix, I want to use this function to calculate each element using this function here. Okay. Now if it's 2 by 2, I think it's pretty simple, because you, by entering 1 to the n, we're going to have 1 right here, and if m n, if you put 1 to m here, I think this is going to become 1. So what you just need to do is to calculate each of those values independently. So it depends where you are right now. If the columns and rows are in the left top corner, you're going to just multiply 2 power 2. If it's on the right top corner, it's 2 power of 2 plus 1 plus 2, and so on. Okay, now when it is 4 by 4, what you need to do is to first enter the value here, enter the value here, 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 here. And since you have additional M2 here, what we're going to do is to have additional 2 by 2 matrix for this one right here. Okay, which means if you are calculating here, I mean if you have started calculating from here, this value will expand to 2 by 2. So I guess what I can say is that when you stop by a single element using these calculations, it will expand to 2 by 2 matrix. And if you do the same calculation for each element again using the same functions, it will expand 4 by 4 because each element will be divided by 2. And if you keep doing this, you're going to have 8 by 8 in the next and 16 by 16 in the next step. Okay, so that's how it's going to work. Now considering that, maybe we can put it into some functions. Okay, so for the dithering, each time you get a column number and a row number, it's a number in between 0 to 3, which you have 3 values, I think. So I could be 0, I could be 1, j could be 0, I mean in this case n, oops, sorry. J could be 0, j could be 1, so 2 by 2 matrix, 2 by 2 rows and column numbers. I could be either 0, 1, j could be either 0, 1. Okay, and the n is the depths of the threshold map, which it means if this is 1, this is 2, and this is 3. Okay. Okay, so considering that, we need to say if let me see Okay, so consider that I is in between 0 to 1. Maybe I can choose which calculation should be done for the combination of these two values. Okay, so if I, can we use parentheses in Python? Forgot. If I modulus of 2 is equal to 0 and j modulus of 2 is equal to 0, maybe I can do this calculation here, which is let's have the variable outside. Value is equal to 2 multiplied by n power of 2. Okay, so if the n is equal to 1, this means you're going to get 4, I guess. Is it? Although, is that true? Maybe this one is not really 1, but by multiplying this one by this one, you're going to get these values. So even if the n is equal to 1, this is not really 0, right? So it's 2 multiplied by 2, so 4. So I guess you need to consider the final m when the n is equal to 1. Do we have that information somewhere? Maybe. Okay, so that means let me just see all the other options. if elif I is 1 and j 0 value is math power 2 multiplied by n and 2 plus 2. Okay, so somehow I need to kind of multiply this by the next m value. Okay, yeah. So I guess okay, I realized that looking at this one, if when the n is equal to 1, then everything is 0, so these are going to disappear. So all you're left out with is 0, 2, 3, 1, which is similar to this one. Okay, now I get it. Okay, so that means if I need to kind of create some conditions here, I guess. If n is equal to 1, then it's 0. So how do I do that? Okay, I'm gonna create conditions here. If n is equal to 1, then I'm gonna create the multiplication value. Initially it's 1, and just multiply it here. Okay, and I'll get back to, okay, this should go side. Okay, now I need to multiply additional value here, which is the next mn. So what I need to do is to multiply additional threshold map here with a new column and rows informations together with the next n. Okay, so n is going to be the next n is going to be divided by 2, I think. So n divided by 2, and just get the floor value. So if it's 1, wait a minute. If it's 1, it will just become 0 in the end. Now I kind of confused what will be the n. So n is here, right? Okay. Right. Now these are a number of for the multiplication of 2. So the starting point for m is 2. So should I make this one as, no, I don't think so. N is equal to 1 here, so it's fine. Okay. Okay, I'll just try to go with these, and yeah, I think it's fine. Let's see how it goes. And the next column value and row value is, you can just pass these numbers as it is, I think. I think, yeah, probably. Is it? So if I choose these values, 1, 2, 3, 4, 5 by 3, only convert it to 1 and 2, 1 and 1 and 0, and now 1 and 1, right? Okay, and in the next loop is going to have to okay, so since I need to do this recursively from this one to this one to this one, in the first loop you only have 4 values, okay, if you're starting from M2. Right, so this means you kind of need to bring the original columns and rows based on the how big the matrix is. And okay. Okay. Okay, I think I'm doing something wrong here. I just let me just think. Sorry for the hustles. I'll try with the simple equations for M2 first, and I'm gonna go back to creating the further threshold map. Okay. So for this one, if n is equal to 1, and if n is equal to 1, and if you're calculating for each element, this one will be just a simple 0, 2, 3, and 1. Okay, so this is the initial condition. Right. And let's create a empty value. How do I call that? I'm gonna call it as devals, as a array. Okay. And what I'm gonna do is to create a number of values, which is going to be the values of the matrix. So if it's 4 by 4, you're going to have 16 values. Okay, so for I n, so in order to do that, you need to bring out the value that I have created and init vex triangle, which is these number of columns and rows. Let's get information. Let's get that information. Int rows. Columns is geo dot attriv value calls. Is that it? Let's check. Okay, so I got these values here. Let's get the rows as well. Okay, now I'm going to create a loop to create 16 values, since this is 4x4 matrix. So for I in range of columns as well. I need a ring length. Okay, as well as another loop for n in range rows. Okay. Now for each matrix, I think I should bring this outside a loop. Yeah. Okay. Okay, so for each value, what I want to do is to use these n and I, which is the number of columns and rows, to calculate the value for specific columns and rows, which are these numbers. Okay, so the value or dval is equal to threshold map let's try not to use n here because it's a bit confusing. Let's go and just use t here, and this one is as s. So dval is threshold map, and let's say n is equal to 1 for initial value. Okay, and the column is s, the rows is t. Okay, and want to append the value that I got to the dvals array. Okay, and probably I need to make this function above. Okay, and let's check what we got as this dval. Okay, none. Let's stop by n is equal to 1. Num is equal to 1. Okay, everything num, so maybe something. Okay, I wasn't returning anything. So in the end, I have to return this value that I've calculated. Okay, so it's 0231, so it's good for the first step. Now the second step, if you have 4x4 matrix, when I increase the mat number to 2, n equal to 2, then I need to do the calculations. After doing this calculation, for each value here, I need to do this function to be calculated twice for each values here. First of all, you do the calculations using this one, then after you got the each values, going to do additional matrix calculations for each one of those values, and as a result you're going to get these values. Okay, so let's increase the matrix number to 2. Now for now what you get is 0, 2, 0, 2, 313102023131, which doesn't really sound like the value that I want. So let's see how I can fix this. Okay, so when an n is equal to 1, I mean 2 in this case, we're going to enter, I'm going to use these calculations. Okay, so we're going to add additional calculations to multiply by n. Math power of 2. Okay. And it's pretty doing the same things for all the other stuff. Okay, so let's copy this one. Okay, now this has to work even if the n is equal to 1. And now the value has changed, so I need to next I need to multiply this mult value, which becomes 0 when n is equal to 1. So let's multiply it here. Okay, so it's a float number, but the value is currently correct if you going from left top corner to go right to the right direction. Okay, now let's make this back to 2. Now next thing that I need to do is to recall the same functions and multiply it. And in this case I don't want to create a matrix, but instead I just want to have a single element, a specific single element, specific areas. Okay, so in this case, let's say if it's let's say if n the column is 2 and row is 1, you get this position here. Okay, and if you split these 4x4 matrix by 2 by 2 matrix, then you get this matrix for this number, and in that case the column number is equal to 0 and the row number is equal to 1. Okay, so yeah, which means it's I think it's okay to use these conditionals as it is. Okay, so what I need to do next is to call yourself as a recursive function, and I also need to create a conditions in order to stop the calculation. So when n is equal to 1, the calculation must stop, I think. Right. So yeah, so which means I need to create additional conditions here, kind of. Let's say, let's have this right here. And this additional calculation, which is using this threshold map, only happens when n is not equal to 0. Okay, so and mn is and it's the same anywhere right here, so I think I can just calculate it here. So else I think I can set the multiplication to threshold map here. Wait, what did I do? I think I did something wrong. Okay. Okay, so else the multiplication should be threshold map using additional parameters. Okay, this way I think I can recursively calculate n stops when n is equal to 1. Okay, so threshold map, the new value will be n divided by 2 for the new n. Let's calculate something like that. And for a new I and j, I think I can just reuse the same one. Probably. Yeah. Now, let's see what happens. No, nothing is happening. Okay, do I get this right? First of all, let's check what the... Okay. So 0, 2, 3. Got to add 1 here. Okay, and let's make it integer as a final value. Okay, now if I increase this value by 2, what would happen? Okay, still not getting what I was hoping for, so maybe this one is something wrong. So I and j, do I get this? Okay. 0, 2, 0, 2. Maybe I need to do something with these I and j here. Alright. So I might need to... Do I need to multiply by 0.5 here as well? Okay, let's see what happens. Nope, not really. Okay. Or this one. Okay, so when n is equal to 2, by dividing by 2, you get 1 for this one. Sure. And It's supposed to it's supposed to get these values right, and then being let me check if what I'm getting here. Okay, so what I'm getting here is 0 in the end. That doesn't sound correct. Well, in the end it's all 0, so that's fine. But you okay, let me just check with the single element. Let's say 0, 1, 2, 3, 3 to 0. So it says 2, which is incorrect. If it's 0, 0, that's 0, that's fine. 1, 0, it's 2, it's not correct. So need to fix that. Let me go over the calculation again. So if n is equal to, wait, I wanted to see it when the n is equal to 2. Yeah, the things that I did wrong is that I set this value to 1, because this has to be equal to this matnum, so I forgot to do that. Let's bring this value up as well and get that number as a parameter, as a variable. Okay, so I need to enter that value right here. Okay, so the result should be something different. Okay, now still looks totally incorrect. If I change this to 1, what would happen? So this one's correct. If n is equal to 2, it's not really correct. So let's fix this up. So this value is fine, but the second value going forward is all wrong. So the second value has to be 8. So let's check each calculations. If n is equal to 2, when I is equal to 1, j goes to 0. What we get is, what we're going to do, first of all, when n is not equal to 1, so this calculation is going to be held. And if you multiply 2 by 0.5, it becomes 1. And I and j is 1 and 0. So you're going to calculate additional calculations here. And in that case, n is equal to 0. n is equal to 1, so you get multiplication equal to 0. You're not going to get these values, so the value you're going to get is 2, right? For I equal to 1 and j equal to 0. Okay. Now going back to where I was. So this value become 2. Now we're going to use that to calculate with this one, is it? So this, which means 2 multiplied by 2, 4, and which is also going to be multiply, I mean using power functions to multiply it. So which is 4 by 4, 16. Now that is already too big. And then you're multiplying by 2 here, so 32 and plus 2. So the calculation is correct, but the way it held is wrong. Okay. So, think I am doing something wrong here. So, so this one, in this, if n is equal to 2, everything will be 16, right? 16. And this one is also 16. Which sounds a bit too big. Okay, what did I do last time? Let's see. Mm-mm-mm. 16. Are we going to... No, there's no negativity here, so... When n is equal to 2... Yeah, 16... If it's equal to... If n is equal to 2 and if n is equal to 1 here, then that's 4 by 4. No, then multiply 4 here and multiply by 2 here. Let me just check if this gonna give something else. Probably not. Nope. I think I'm doing totally wrong here. Okay. Let me check what I have written previously. See what I'm doing wrong. Okay. Okay. Seems like the function that I made previously for this threshold map looks a bit different. Now, if n is equal to 1, having multiplication equal to 0 is fine, but in other cases, first of all, I wasn't multiplying this by 0.5, but I was subtracting by 1. Okay, and somehow Well, I have the right answers, but I can't really explain why it works, so I don't want to use that one. Kind of want to follow what it says in the Wikipedia. Okay, so let me see if I can have additional explanation to this threshold matrix. Maybe I can change the language. There's one in Japanese. Let's see if I have additional informations here. Okay, well, something looks different here, isn't it? Doesn't have n here. What? This one and this one kind of looks different, isn't it? This one just have 4 as a constant value. This one has n. Huh. Well, that seems different. Okay. That doesn't sound right. So let's say I follow this one instead. So that means instead of having all these calculations, I'll just multiply by 4 here. Multiply by 4. Well, still, I get not getting the result that I want, but next step. Okay. Let's see if how. I'm just going to draw some sketch here. See how is it actually possible to get this result. So 0, 0, 2, 3, 1. Okay, just show up. Okay, and if n is equal to 1, meaning m2, this is m2, right? Isn't it? No. Wait a minute. Yeah, m2 is this value here. Okay, so m4 when n is equal to 2. 2 multiplied by 2, power of 2, 16, 1 by 16, and for the matrix, I'm going to have multiplication 4 by 0, 2, 3, 1, 4 multiplied by 0, 2, 3, 1, plus 2, 4, 0, 2, 3, 1, plus 3, 4 by 0, 2, 3, 1, plus 1. Okay, so as a result, that is 0, 8, 12, 4, which is equal to these one, 0 plus 2, 8 by 2, 8 plus 2. Okay, so 14, 4 by 1 plus 2, so 6. So I think the algorithms is correct. Okay, so the way I implemented is wrong. That's the problem. Okay, so I need to fix that. Okay, so I am guessing this one is something wrong. So, which is this one, right? Okay, so hopefully these parameters is correct. I'm just dividing the n value by 2, right? Yeah, so when I start the n multiple, maybe this is not the division by 2, but this is just subtracting n by 1, isn't it? Isn't it? This, I'm not really getting this one. Where when n is equal to 3, right? Which means you have n 2n, so 6. The next one will be m3, which does not really exist. Huh. That's problematic. Okay, well, I assume that the value that I need to input here is not divided by 5, but it's rather n subtract by 1. In those cases, I mean, it should work, but the way it's written here is something a bit different. But let's say if it's 2, if n is equal to 2, that doesn't really matter. The result is the same. So let's go with this for now. Now, for I and j. Okay, so let's write this again. If I am looking at this value here, I is equal to 1, j is equal to 0. Okay. The first step, for the first step, I need to calculate with these one. Okay, so it's going, previously I was going from the biggest one to the lowest one, but actually I need to go from the lowest to the end, one by one. So that, I think that was the problem. Yeah. Okay, so in that case, what I need to do, I need to so the way I use I should be something different. So for the first loop for n, when n is equal to 2, maybe I should have two numbers. One is the current n, starts from 1 and goes up to the end where I want to stop. So I'm going to recreate the functions with new parameters. N will be the current number. The second parameter will be the actual mat number, the final mat number that I want to use. So, which means I'm going to enter 1 for the first one. So in any case, the first parameter will be 1 in this case, and what I'm going to do is to update this one until it gets to the same number as num. So that means the value that I'm going to write here is more of something like that, isn't it? No, I think it's the other way around. Is it? It's the other way around, isn't it? Well, let's check with these. Okay, now so if n, maybe I should start from num. Wait, is that correct? Okay, I'm a bit confused. So the first value is for the calculation will be this one when n is equal to 2. Yeah. So probably I think it's just fine having these after all. Okay, now let's say n is equal to 2. Okay, so when n is equal to 2, what I want to do here is first of all subtract this by 1 for the threshold map, get I and j, and let's say let's say if you have this value here, and if you on the next matrix you want to convert this number to this area, or this area, or this area, or this area, or this area. So the value which is in this area should be these area, I equal to 0, j equals to 0. If the value is in this area, then the when you on the next threshold map calculations, the value has to be this area, I equal to 1, j equals to 1. So this has to be divided by 2 and make it as an integer. Same for the j. That's what I was missing, I think. Now, how's that? 0, 8, 2, 10, 0. Okay, the order is kind of different. 12, 4, 14, 6. Okay, maybe I need to think. No, that's not it. Okay, so I think I have to consider the order. In this case, I'm just appending the value as when it's being created, but instead of appending it, I think I just need to replace it on the specific order, which is more robust. So what I'm going to do is to first of all initialize this deval value by the number of rows and columns. Then I'm going to replace the value that I've created here with S and T as an index value. So the column is S T multiplied by number of rows. Okay. Equal to dval. And indentation error. Okay, this one. Okay, so what do we got here? 82, 802, 810, still wrong. Still wrong. This is a column, right? And this is, so index wise, this goes from left to right, from top to bottom. Yeah. So I was hoping this is correct. So this is column, this is row. Is it how it's being used? So column, row. If the column, so this one is correct, I think. So this, if I, which in this case a column, is equal to 1, yeah, I think this is correct. But the order is kind of not wrong, not correct. It says 8, 0, 8, 2, 10, but it says 0, 2, 8, 10, so the position where 2 and 10 is wrong. So that is, I guess this is the calculation that I did here is somewhat wrong, for sure. So let's see, let's rethink. Okay, so this one, I is equal to 1, j is equal to 0. Okay, and I want to convert this into I equal to 0, j equal to 0 for the previous matrix. So what I did here, I multiply I by 0.5 and floored, which becomes 0. Same for j. So which you get this value here. And that part, I was hoping that part is correct, but it is not. It's not. Wait a minute. So what if I have that value? Okay. So for this, for this positions, so for the previous map, I think I need additional threshold map to this, isn't it? Doesn't it? Now I think I forgot this one right here to add to this M. Right. I think in order to calculate the correct values, need to also divide by these values right here. Okay. So for this one, starting off 0, split it into 2. You have 0, 2, 3, 1, and you're multiplying by these values, so 0. Huh. Yeah, so each one of those will be multiplied by 4. Okay, and if is that what's happened here? It's what's happening here. So maybe not. Maybe, well, if I and j is equal to 0, I'm going to use this calculation here. Right. Right. Hmm. 0, 2, 3, 1. So I think you always need to start with these. I think it's easier to start with these values and recursively increase these. So the way I write is maybe not so good. I think it's better if I create this as an initial value, then I don't know, increase this. Okay. Just gonna copy one more and let's just create a initial value 0, 2, 3, 1. Okay, and I'm going to use this threshold map, or gonna call it as an init map, and I'm gonna use this inside the threshold map. Okay, so when n is equal to 1 and I just going remove all the conditions here. I'll just say if n is equal, I is equal to 1 and j equals to 0. Get this value here. If I is equal to 1, j equals to 0, get this value here. If I is equal to 0, j equals to 1, 2, if I goes to 1, okay, j goes to 1, okay. Each time I do this, kind of forget how I made this. It's fine. Let's remove all the. Oops. Where am I getting the error? 27. Okay. Now, when n is equal to 2, first of all, it's more than 1. Then I'm going to make this smaller. So I is multiplied by 0.5 floor, as well as j. Okay, so hopefully if the value is right here, you are looking at I equals to 0, I equals to 1, j equals to 0. Right. Okay, and we want to use this value to get the value right here. I'm gonna create a new variable just in case. and let's say if n is equal to 1, the value looks like these. elif, okay, and the value starts with 0, is that it? Maybe. Maybe I shouldn't call these a value. Okay. So this is more of a multiplication, right? So let's call this mult equal to 1. I mean, maybe the value is fine. Just call it, I'll just call it 1, and if n is equal to 1, then everything is going to be replaced with these values. If not, the value will be multiplied by the threshold map. Okay. Right. And what do I get here? And things that I am missing here is these multiplication. Wait, so when I do this, I think I might be better off incrementing this, and in this case I need to know when to stop it. So the value okay, 4 multiplied by threshold map plus init map wait a minute, I can just say value equal to init map I plus j multiplied by 2. Okay, same for these, I plus j multiplied by 2. Get errors somewhere. 31. Threshold. Oh, okay, well, forgot to. Huh, 18 threshold map, index error, list index out of range. Okay, so this one seems it's too big. which means I or j is more than 1, which is not ideal. Alright, that's because I have it here. Okay, now I'm starting to get it. The reason why I'm getting these errors is because in the end I still need to start from these values and end it here, which means in order to get the initial map, this point okay, let's create a new value here. Sorry for being so hustling here. I mean, I wasn't planning to take this long to create this threshold map. Well, I think just studying by implementing it. I mean, I once did implement it by myself and it worked, but now I totally forgot how I did. It's kind of my problem. So we know the maximum number of n, which is the number, so we can estimate the maximum number for columns and rows, which is max number is math power of 2 by n. Okay, so if it's if the number is 2, it's 2 by 2, so 4. If it's 3, it's 8 by 8. Okay, now I can now create a new value for I by dividing this value by float number of max number, then do the math actually divided by the half number of maximum number, which will give you volume between 0 to 2. And if you create a floor value for this one, you get either 1 or 0 or 1. Same for the j value. Right. Which is the one that I wanted to use it here. Okay, and for this one, I think I need to rethink. So when I decrease the n value by 1, let's say I started from 2, I also need to update this I value here as well, which is, I think it's fine with these value. Yeah. But I need to change the name, so I'm gonna call this NI, and nj. Okay, now what am I missing? Well, I need to do the same thing here. Start by 1. So 0, 2, 3, 1. It's fine. If I increase it by 2, 0, 0, 10, 10. Okay, totally different. Totally looks different. So the first, these 4 square values is becoming 0 in this case. That's not correct. So why is that? That is because I don't have this addition. Well, I do. I kind of do. Okay. When I is 1. And which means the maximum number is equal to 2. Okay. What am I doing wrong here? Okay, I'm multiplying 4 by these threshold values, which is again, so if this is equal to 1, not really sure why. Okay. Okay, let me think again. So when n is equal to 2, the maximum number, this one becomes 4, maximum number will become 4, and you multiply this one by 0.5, so this will become 2, and dividing with I, which is in between 0 to 3, I think. So as a result, you get 0 to 1.5, and if you do the floor calculations, you get either at 0 or 1, and same for the j, 0 or 1. Okay. Now if I am looking at the, let's say, this value here, which is I equal to 0 and j equal to 3. In that case, j will become 1, I will become, so I is equal to 0, j equal to 1. Now, since n is more than 1, what I'm doing here is, and I is equal to 0, j is equal to 3. Right. So this one gives you 0, and this one gives you 1. So what you're going to enter here as a new threshold value is 1, 0, 1. And this value here that I'm going to get is 0 plus 2, so get 3. And this value here, what you get is, since n is equal to 1, so just going to get the new ij value, which is 0 and 1, and you're going to divide by 1, so you're just using the same value, and the value you get out of this one is 0 plus 2, so again 3. So that's 3 multiplied by 4 plus 3, so 15, which looks correct, but I'm not getting that value. Okay, so what is up? Maybe I'm doing something wrong here. Oops. Why am I? Okay, I think my keyboard lost the connections. Let me reconnect my keyboard. Okay, so I am not getting that value for some reason, so let's see why. Let's just check with the single value here. Num2, the s is 0, t is 3, and what I'm hoping to have is 15. Well, I am getting that value. Okay, 0, 1, 2. What if I say 2 here? 50. So that's wrong. That's wrong. And what if I say 1 here? It's wrong. So if it's equal to 0, 1, what would happen? I'm hoping to get 12 as a value, and so 0, 1. And this value here, I is going to be 0, jj is going to be 0, and since n is equal to 2, I'm going to calculate this one. Ni and an nj. If I divide these two values, you get 0 and 0. That doesn't sound correct, does it? Okay, now this one, the initial map here using 0, 0 will become 0. Okay, and for this one, since I'm entering 0, 0, so this seems wrong here. I might need to say like that. Okay, now I got 12. So let's see what I got with all the values. 0, 8, 2, 10, 12. Okay, finally I seem to got the value I wanted. Oh wow, it took a long time to do this. So mat num equal to 3. Do I get the same values as this one? Nope. Okay, another problem. Okay, so I am not getting the same number here. It says 0, 32, 0, 32, 2. So again, some other problem, which might be related to this value here. Is it relate? Well, so if n is equal to 3, n is equal to 3, which means this one. What you need to do for this one is to divide this into 2, like you did previously. And for each one of them, I'm going to refer to the previous matrix. So that part is not being done. And that is related to how I calculate the new INJ. Right. So I think what I need to do here, especially for this one, it's not really equal to 2, but it's the next maximum number, which is n minus 1. Okay, now still not getting the right value. 0, 32, 8, 40. Let's see if this is correct. So if this is 3, then will be 2, 4 by 4. Yeah, I think this part is okay. Now let's think about this part. Okay, so dividing it, Now, this part, I think, yeah, well, this part needs to be either 0 or 1. So, the way I did it must be correct. I hope. If it's 2, so this is correct, right? If it's 3, it's not correct. Oh, wait a minute. 0, 32, 8, 42, 34. If you look at the column side, it seems correct. I mean, yeah. Seems like the order has been switched for some reasons. Huh, why is that? When I say 2, so this was going horizontally. Wait a minute. Maybe the matrix written in Japanese Wikipedia is wrong. It's different than the one it's written in an English version. Oh wow. What a mess. What a mess with these informations. You always have to have multiple sources to check. I just proved it. Oh, stupid me. So, seems like I got the right values finally. So 0, 32, A 42, which seems correct. So by changing these numbers, I'm able to have these threshold values, which is equal to what we have here in Wikipedia. Okay. So hopefully when I make this to 4, you got the correct values, which is 16 by 16 values. It's a lot, so maybe I'm not gonna use it. Maybe 1, 2, 3 might be enough as a threshold value. Oh wow, took a long time to go till the end. Each one of them has different equations and results, which made me so confused. But anyway, finally I'm at the starting point, and it's been like 2 hours doing this. Wow, what a waste of time. Anyway, finally got the final calculations. Let's try to use this in OpenCL and Copernicus if you are still here. Okay, so what I want to do this is to store this in an attribute as a float array. Currently what I have is an integer value, so I want to make it as a float value, normalized float value from 0 to 1 for each value. So in order to do that, what I am going to do is dividing this value by what's being said here, the total number of matrix, which in this case 8 by 8, this is 4 by 4. So I have that information, which is S multiplied by T. And let's make sure to make it float. Cannot do that. 0 division error. Okay. Sorry, but it has to be rows and columns. Okay. Okay, and let's check that value. Okay, so this is the normalized value from 0 to 1, which I'm gonna use it as a threshold value. Meaning if the value, the color value is more than like these values, you're going to make it as a white. If the color value is less than this threshold value, then make it black. And as a result, you can get a dithering map. Okay, so I wanna store this as an attribute, so let's create a initial float map, float attributes called as devals. Like that, like this one, and store this deval that I have created here to this attribute in Python. So geo set, what was the name for the global attrib value? Was it? Maybe not. It's not the function name, but let's try devals with. Okay, worked. Alright, so finally I'm at the starting point, and this is where I'm going to use these threshold values to implement the dithering. And once I have this threshold map, it's pretty easy. What you do in Copernicus is pretty easy. So you just need to pass those values to OpenCL and do image processing. That's it. Okay, so let's do that. Before doing the actual implementation with the Copernicus for the dithering, I have to prepare some image for the dithering. So let's get it somewhere. What I'm gonna do, since I am subscribed to a Envato element, maybe I can download one of the videos from here to test it out. So last time I tried this one, but anything is fine. Let's just choose some image. Okay, maybe this one, image of kids on the school bus. Okay, so this is for the YouTube. Let's download this and let's try this out. I am not gonna include this files as a sample file because this is licensed, so I'm just gonna try it out just on the live stream. So should copy this file that I have just downloaded to the folder, today's folder. Okay, so I have this video file, MOV file here. So let's try using this in Copernicus to dither. So I'm gonna use the file node to refer to that image to video. If I play it, yeah, it runs. So what I'm gonna do is to try to dither this one with the ordered dithering algorithm. Okay, so first thing first, I have to refer to this value here, to this attributes here inside the Copernicus. So let's import that information. I'm gonna connect this into an info null node so that it is easier to refer to. Then inside the Copernicus, I'm going to use a sub import to get that information value. Now there's a detail attribute here, so what I'm going to do next is to get this informations with OpenCL and using the same OpenCL to do the image processing for dithering, in this case for this image, for this video. Okay, finally, so for the image, for the base dithering image, I'm going to connect to the source. Now first of all, let me check the resolutions. So it's HD 1280 by 720. Maybe I can also create a resample node in between to control the size. Let's just go with 1 by multiplication of 1, so with the HD size, and see the result with these one. And since I'm going to do the dithering, maybe the filter could be point instead of box. Now it's time to connect this sub import information to the OpenCL to get the attribute informations. So I have several parameters that I want to import from sub import. So I have 4 values. One is the array of float, one is the integers for number, columns, and rows. I think I want to get all of these values to be used in OpenCL. So let's do that. So first thing first, I need to have 4 input to get these values for OpenCL. So what I'm going to do is to go to the signature tab, add 4 value here, and name it as the same name as is shown on the detail attribute. I think it needs to be the same value, same name. Maybe not, but I think it's safer. So devals num columns and rows and method. Okay, and since I'm going to refer from the geometry, let's change this to geometry. Okay. Right, now let's connect the one single geometry output to everything here. Right. So I need to do one more thing in order to actually get the attributes, is the binding. I need to bind the attribute to these input, which you can do it either here or here. Maybe this is easier, but because you have GUIs to control, but I'm not going to use this one, but instead I'm going to use the text-based binding, which is more clearer for me. It's easier to, it's a bit easier for me to do it. Maybe not for some people, but in my case it's easier. Now I have 4 detail information, so in order to get the detail attribute, instead of saying layer, I'm going to say detail. Then write the attribute name. In this case, the first one is devals. And you also have to specify the type of that attributes. In this case, a array or float. So do the same for all the other detail attribute. This is integer. This column. This num. Okay, so this, I think the binding has been done correctly with these. Let's check out. So in order to check, let's go back and see what the column number is. So currently so the mud number is 3. So let's see if we are really getting this 3 as a value. So int mud_num is equal to mud_num. Hopefully this is 3. So let's see by replacing this to float for mud_num 0 0 1. So if this is 3, you get really bright red. Okay, and if you divide it by 3, you get 1. And if you replace this by 1, if you get the same color, yeah, which means you're getting successfully getting the mud_num as it is. Okay, so I think it's working. Let's get all the other values. Now, the problem with the float value, you cannot just say devals is equal to devals. This will not give you the float value, but you have to kind of cast it in OpenCL way in order to be able to use the float attribute, float array attribute as an array inside OpenCL. You have to cast it as a pointer. Okay, which took a lot of time for me to figure it out, but the way you write is like this: global float apostrophe devals equal to, cast it with a global float apostrophe. And this way you'll be able to cast a float array into a pointer, which then you can use it similar to how you deal with the array in Vex. Okay, so let's try that out. Devals 0. So this will give you first index of the value. If I say 1, if I say 2, you see you're getting different values in different indexes. So I think I'm getting the correct value, I mean as an array. Okay, so that's the basic setup. Now we can use these informations to actually do the dithering. The first thing first, let's do this easier one, which I mean by using black and white dithering. So in that case I need to get the brightness from this image, so I'm gonna use a HSV adjust node to make it black and white or grayscale image by making the saturation scale to 0 so that there will be grayscale image. Now from here I'm going to get a brightness informations, either red, green, or blue channel, and use that to compare with the devals or threshold map informations. And if the brightness pixels is more than the threshold, then make it white, otherwise black. Now let's say the devals is 4x4. Okay. In order to use this, I'm going to split this image to a collection of 4x4 pixels. And for each pixels, and for each cells, you have these numbers inside, which is in between 0 to 1, actually. Okay. And for each pixels, compare the brightness with the threshold map. And if it's lower than the threshold map, make it black, otherwise make it white. And do the same step for every pixel set trimmed by or divided by these 4x4 matrix. Okay, that's the things that I need to do, so let's do that. Okay. I know the number of columns and rows here by using these informations. So the first thing I need to do is to convert the current x coordinate and y coordinate into a value in between 0 to the number of columns -1 and 0 to number of rows -1. So what I'm going to do, first of all, you can get the x index for the image by accessing to ix, a global variable. So you can then calculate the modulus with a column to get the index for a threshold map for x side, for x directions. Do the same for y. Okay, with the rows. Now now that you get x and y, you are able to get the actual values on the 4x4 or 8x8 or 16x16 threshold map using these index informations. Okay. So the index, since we're using the single array as a devals, we need to convert these two values into a single index for the array, and that is x plus y multiplied by number of in this case columns. Right. Okay, so this is the index, and now you'll be able to get the deval in this specific index, and then you can now compare the current pixel brightness with this deval and change it to either black or white. So the current image is source, and you can access to the red channel, which is grayscale value, and compare with the deval, and if so, if it's smaller than the deval, make it black. If not, make it white. So either 0 or 1. So float value. Okay, and replace this one, these colors by value. See the result. And there you go. An easy step to do the dithering. Maybe the resolution is a bit too high. Let's see, reduce this like that. And it's already working for animation. It's pretty fast. Oops. The end of the frame is 187. Okay, so that's for the black and white dithering, which was easy. Now let's think about how we can dither in the color mode, which also have an explanation in Wikipedia how you can dither the color. In order to do that, you need to kind of quantize the color map in specific steps. So you need to know how many steps you want to have as a quantization. In terms of the black and white, the quantization is either 0 or 1, so it's the minimum. So 2. Okay, either 0 or 1. But you can do the same for a color map. If you do the quantization of 2 for color, then you're going to do the quantization for H channels, red, green, and blue. So going to have in the end, in total, 8 colors, I think, combining each red and green and blue, either 0 or 1. So in total you have 8 colors. And increasing the quantization number, you're going to massively increase the number of colors you can use. Okay, to be used for the dithering. So let's try doing that. So to do that, you need to split the color channel into 3, RGB, which you can already access it inside OpenCL. So I'm just gonna directly input the color value here to OpenCL. Now currently this calculation is being done using a red channel, but what I need to do is to do the similar operations for all the channels: red, green, and blue. Okay, and if I use this conditionals, I can only have 0 or 1. So instead of using conditionals, I need to kind of quantize with any number of divisions or steps. So instead of using conditionals, let's try other method. So to do that, I need to have additional parameters, which is the number of quantizations in this case. So let's state that somewhere. Maybe I can state that in the same attribute here. Like that. And import it back to OpenCL just as I did last time. So let's say quantize 3, and let's get this information, the detail attribute called quantize, on OpenCL again. So meaning I have to add additional parameters here. It's called quantize geometry connected and bind it quantize int. Alright. And get that information. Okay, oop. Getting an error. Quantize int. Do I get that information? Quantize. Quantize, yeah. Signature, quantize, yes. That's correct. Binding, bind, detail, quantize, int, integer, okay, forgot to close it. Alright. Now, since, as I told you, I need to do this for every channel, red, green, and blue. Let's do this one by one. So for the red, first of all, I'm going to get the red informations from the source image, which is this one, which is this colored video. And you can access it by accessing to the first index of the source. Okay, now next what I am going to do here is to use this d value that I have here, okay, to be added here and divided by this quantized information. Quantize divided by quantize. Now since it's been divided, I need to make it back to the reason why I did this is to, so this by doing this calculations, there's a chance that the value will go above 1, right? Because it's adding. If the initial source value is equal to 1, then there's a chance that this value itself will become, the addition will become more than 1, right? So in those cases, I'm going to floor it. So you get either you are going to get an integer value out of the calculations. Wait a minute. Actually, what I need to do is to first, after dividing these values, forget about the floor for now. I'm re-multiplying this by the same quantized value. So in the end, you'll get something which is more more or less more than 1. Okay, so that's when you want to do the floor calculations to make it as an integer. And probably I might need to subtract this by 0.5 so that the in order to make the threshold this value to be in the middle part. But let me just try. And finally, after making this as an integer value, you need to make it to a normalized value back again from 0 to 1. So I think it makes sense to make quantize. quantize this back. And why it's not working. Let me see. Let me check one by one. Okay, so this is not working. Is this the problem? Nope. Is this the problem? Let me see. Nope. Is this the problem? Somewhere else. Seem to have an error somewhere else. Select deval's index. Huh. I think it was previously working and now somehow it's not working for some reasons. Huh. Not sure what did I do wrong. Let me go back to the previous. Okay, so this part is working. Somehow after this I did something wrong. I don't know what. Do we have a quantization? Yes. Quantize, yeah. Let's bring that out again. So quantize. Do we have it? Yeah. And okay, so hopefully I'll be able to go from here. Okay, I was missing value. Maybe that was it. Maybe that was it. So let's start from beginning. So I was getting the source value, the first index for the source, which is in the red value, and then subtract by 0.5, then add it by value. Using the quantized value. Multiplying this by quantize, which will give you an integer value. Right. I'm not sure if I need this one. Maybe not. Let's see. I can try that out. Okay, and it's finally normalizing it by dividing by quantize. And let's try replacing R with the value that I just created. And it seems all washed out. Doesn't look correct. Nope. If I don't have 0.5, okay. Start to have some image here. Let's see. I don't think I need to do float here. What if I don't have these divisions? Nope. And subtract it by 0.5. Maybe, yep. Okay. Now, where did I... Okay, I forgot to... Currently, I'm just using the values as it is, but I need to use the deval, which is a dithering value. Okay, now seems like I'm getting something here. So this is for the R, but I want to do for all the greens and blue colors as well. So change the channel here and replace these. See what happens. Okay, so seems like I got something. Let's see if this is color-wise correct or not. I'm gonna make this to front view, compare with the original color. So it looks a bit darker to me. So probably it's due to the subtraction that I have here. So let's remove this after all. Now it's too bright, so divide it by quantize here. Now it's pretty close to the original color. Yep. So I think this is it. Yep. And if I change the sample a bit smaller, you see you're getting a dithered image, dithered videos. Alright. And if I change the value for the quantizations, going back to the initial values, you see if the quantize is equal to 1, which is in this case a binary 0 or 1, you get either the red, green, blue, or all the other 5 colors, including white and black. If you increase more, starting to get original color more and more. Starting to kind of lose the dithering effect as well, so maybe keeping the quantize smaller is a nice idea, good idea. And changing the matnum also changes how it looks in terms of the dithering. Low numbers gives you, if it's equal to 1, then it's by 2 by 2 matrix, just a simple dithering here. Okay, maybe 2 or 3 may be nice here. Okay, so overall it's working great, and you could save this as an image. I think forgot how you can do that. Save image. Let's see how it's gonna be saved. I'm gonna save it as a PNG, see how it looks like. So this is the image that I got saved. Yeah, it's a dithered image. So I think everything worked just fine here. Now that was about using a ordered dithering using the threshold value called Bayer matrix. But you could also use your custom matrix as well in order to create some custom like dithering, which might opens a little bit more like possibilities how you visualize your image using the same algorithm that I set here. So if you go back to the Wikipedia and check these map informations, you can consider it as kind of a grayscale map in different sizes. For this one, you can consider it as like the 0 could be considered as white image, white color. 3 could be considered as black, and this 1 or 2 could be considered as gray scales and so on. So one I could kind of see some color map from these matrix, meaning if you prepare the same like color map as these numbers using as a grayscale value, you'll be able to just use that image to create these dithering effect. And what's more is that you could also create your own dithering map instead of just using a Bayer matrix, and use it as your custom map for the dithering. And in that case, the map doesn't have to have the same column and row numbers, but you can actually change the size or the shape. So let's try making some custom map, let's say 3 by 5, and using the grayscale color to create some map which might going to be interesting. I'm not sure how it's gonna affect, but let's see how this is going to affect. Now if you look at the Bayer matrix, every value is different, so it might make sense to make every color different, but I'm gonna be a bit lazy here, just trying to use same color at some point, at some bases, and see how this map is going to create as a dithering map. So let's say I have created this map, which it's a bit hard to imagine how this gonna convert it into a dithered map, dithered image. But let's see if I can use this or not. So I'm gonna save this file to today's folder as map information. Let's call this threshold, and since that's an image, you can just import it inside a Copernicus network. So using file and refer to the threshold. Okay, and you just need mono informations for this one. And what else? Yeah. Now, since this has different columns and rows size, I think I need to get the size information somehow from the image. Okay. But I think I can just do that by connecting it as an image or layer to an OpenCL. So let's give additional signature to the OpenCL. Let's call this threshold map or T map. Okay. And I can go with mono. Let's say optional. Go back to kernel. It's binded. So bind layer. The name is tmap and it's optional, so you need a question mark. And the default value could be 0. Okay. Now let's connect this to here. Let's try to use this as a threshold map. So let's say let's choose between the Bayer map and the threshold map with some additional like informations or flags. So I think I need to have some conditionals. Maybe I can make the default value to -1 for this tmap value. Okay, and let's create a conditions. If okay, float. Okay, so also I want to make this as a float value. So if first of all, let's get this tmap. If this tmap is equal to is not equal to -1, then I can update some of the information that I have here, including the columns, rows, and devals. Okay, so first of all, the column is the size, the x size of this image tmap here. So that is tmap dot what? I think I need to look for the documentation. Okay, let's check the OpenCL for Vex users, and we're looking at the layer binding method. Do we have an X size? Yeah, there you go. So you have a resolution informations for the layers. One is called XRes and one is called YRes. So the column in this case is tmaps XRes, and rows is tmap YRes. Okay, now the other information that I need, quantization is fine. The next value is the actual D value here, so you can place it here, and when the tmap is not equal to -1, then you are going to get the actual index value here. Now the index is somehow related to this one. I mean, you can just use the same one, but since columns and rows are updated right here, actually you can just place it after this one, and this part might need to be updated for the deval. If so, I'm gonna create another conditions. If tmap is not equal to deval -1 again, then the deval is, you can sample the value from this textures using these x and y value here. Okay. Well, in that case, maybe x and y will be a different value, so I'm just gonna give it like this, and so that you don't have to have two conditions. Okay. So, in order to sample the texture color from the layer, you need to make a UV first. So, let's call make UV. The first one is related to the IX value, which is a current image index, a modulus the column, but at the same time you add 0.5 to this so that you are looking at the middle of the pixels. Then finally divide this value by columns so that you get a normalized value for the x informations. And do the same thing for the y using rows. Okay, now you get the UV. You can use this to sample the textures for a deval from a tmap. So tmap, so what was the function? For the layer, in order to sample the textures using UV, you can use this one. Texture sample function. So texture sample UV. Okay, and I'm getting error. Okay, let's go by one. The error message on OpenCL is a bit hard to see, so seems like the calculation here has some problem. I realized I cannot use this modulus for this values because this is float. Float with these signals is not supported on OpenCL, so instead of using this symbol, I need to use something else, which is to use fmod function. Okay. So that's for the that's the modulus function for the float. And do the same for this one. Alright. Now update the deval. And there you go. This is the result of the map that I have created like this. Is it true? I'm not sure. Let's make everything white here, and let's make just this part black. See how what's gonna give you as a result. Reload. Wait, did I save it? Nope. Reload the image, and you get something like this. So it's really hard to see, but it's showing something. It's maybe I need to make a grayscale here and a little bit of whiteness here. How's this? Tricolor colors. See what happens with these. Reload the image. Okay. So something like that. It's no longer a ordinary dithering image, but something more customized dithered image, which might gives you some possibilities to create your own pattern. Let's give different size, something like 8 by 8, and make it all, I don't know, white for now. Slightly bright gray, and maybe creating some smiley faces. See what's gonna give. Maybe making everything too white, it's not gonna give you a better result. But let's see. Let's play out. And there you go. A smiley dithering. Now that you see something like this, I mean, you might be able to use multiple number of threshold images. Not just a single one, but maybe using multiple image based on some conditions we have from the image. But that might also be interesting, isn't it? Let's try that out. I mean, it's just time for me to play out, so maybe you'll get bored with this, but bear with me. So let's create additional layer to this one, this image. I'm gonna duplicate it. And let's make a sad face. Something like that. I think I'm not using the same colors, eh? Okay, so this is additional image. Let's call this threshold 2. Get that information. And connect this to an OpenCL as an additional one. So let's create a new one. Tmap 2 as a mono, optional, kernel, just binding it with the same information, just rename it. Okay, and assume these two shares the same size. Okay, what I just want to do is to replace just choose either one of the tmap based on some conditions of this image that I have here. Maybe I can refer to some brightness, so maybe I can have additional information here connected to the OpenCL as a brightness information. So let's give additional signature here, somewhere right here. And let's make it mono. And I think I can just connect it here, or maybe I need to split it into a single channel. Just get the rep value. Okay, then connect the tmap 1 and tmap 2. Alright, now now I am going to get the brightness binded. Layer brightness float. Okay, this is not optional, so you can just say like this. Okay, so the conditions. Let's also get the tmap to so let's say if brightness is less than 0.5, you use the smiley face. Oops. I forgot to get the brightness value. Okay. So if I change the conditions to the other way around, it's a bit hard to see because maybe let's say 0.25. Okay, now some parts are being used as a smiley face here. So else I can pretty much copy all these, and instead of using tmap, let's use tmap 2. So based on the brightness, you see that you can also change how it's dithered. Instead of using this smiley face as it is, you can use the original dithering, and I don't know, maybe you can use the different types of dither on the other places. So Yeah, you can do a lot of things with these. It's pretty easy to set up. And I don't think I would want to actually use it anymore. Maybe mixing with the face and the original dithering is just fine. So I'm just going to remove these tmap to binding. Which was a bit of too much informations. Okay. Okay, so let's try changing the original this one to something that has more grayscale image here. Let's make it smaller. Canvas size to 3 by 3. Yeah, something like that. Reroll the image. And there you go. You see some different dithering based on different conditions. Yeah, which could be interesting. If you change the conditionals upside down. And these parameters are changing for the dithering, the Bayer based dithering, but these ditherings are based on the image map. You can always combine them together. So I think it's pretty interesting. Yeah, so that's how you could do a dithered dithering to the image. Now let's try this out using some custom geometry on the SOP network, like a pig head, and make it dithered like I just did for the video. Okay, let's create a camera. Let's make the size of the camera to be squared so that it fits with these pig head. I can make it as a perspective. The size, let's make this squared. Okay, let's create some simple animations for this big head as well. Just to see. Some changes while doing the dithering. Okay. So let's call this Geo. I'm gonna bring that information using another SOP import. Now this time I'm going to convert this geometry into an image by rasterize geometry. And let's also use the camera informations. Okay. Now, currently this is black and white. Just shows you the alpha channel, which is fine, but I want to get the color informations from the geometry, so let's get the texture value. Let's get the UV first, UV information first. So add UV. So this UV can be used to map the texture onto this image. So in order to do that, you need to have a texture itself. What texture is to be mapped? So going to a test geometry here, you need to know where the texture is. Let's just get this pig texture right here, which is under textures. So let's copy this parameter. Going back to cop and using a file network to refer to that information, which is a pick texture. So I'm gonna try to map this into this UV information by texture sample function. As a result, you'll be able to map the textures onto a wide area. Okay, now if you play it, you're seeing a rotated 2D pig head. Now, it doesn't have a shadow information because it's just a image being transferred from texture image. So if you need to have light informations, I think you need to also calculate the right directions and so on. I'm not sure if it's possible to capture the things that you see on the viewport as it is. I'm not sure if that's possible. From what I hear, from what I see here, you could get all these attributes, but maybe not the view as it is, as an image. I'm not sure. If you know something, let me know. But at least for now, I don't know how, so I'm gonna go with this image here. Okay, so I have the rotated pig. I can now just replace the video file with this pig head just to do the dithering. And since I have two types of dithering, you're seeing some kind of interesting effect here. And you can change it by controlling the threshold here. Okay, so if I make this to 1, every part of the pig head is using this image based dithering. If I make this to 0, it just uses the order dithering Bayer matrix. Okay. In this case, maybe I can make it smaller. Okay. Now, I might want to make the background to be white, as well as having some like outline to this one. So let's make that as well quickly. In terms of the background to be white, I can just invert this alpha channel and just add those two images together. to make the background white. And in order to add some outline to this one, to this pig head, what I could do is to, from this alpha channel, I can erode this outline, this alpha channel a little bit, expand it by eroding it, then do the subtraction between the eroded one and the original alpha channel, which will give you some outline informations, and you can control the amount of thickness by changing these radius value here. Okay, now what you could do in order to use this as an outline is to do the subtraction between the image and these black and white image. Now you're going to get a black outline. Simple as that. Okay, maybe I want to increase a little bit more thickness to this one, like that. And then connecting to an OpenCL gives you a result after being outlined. Yeah. Yep. Simple as that. Okay. So I'll give a switch so that you can switch between these images, videos, or geometry. And maybe I can also give a switch between the null and the image. Okay, maybe null is not supported. If this is equal to 0, maybe it's, yeah, input 1 is missing. Okay. In that case, it's either disconnecting or not. Yep. Alright, so that's pretty much it for the dithering. I mean, I think with these steps you could try out like many dithering effects as possible, as much as possible. I think especially the custom dithering map type which you can use to create your custom map is pretty useful for the exploration. You could also create a more of a diagonal map as well. Let me try. Let's go with 4x4. And let's give something like these. More of a diagonal Let's also try to change these colors, grayscale map a little bit, which works to have various number of colors in different places. So it's better you have various number of grayscale colors for sure. It's pretty randomish that I'm doing right now. Hopefully we'll give you some interesting results too. So more or less it's you see a contrast between the black and white colors. So let's see what this will give you as a result. Okay, so something like this. It's a bit hard to see what's going on here. Let's change the map to... Okay, so something like this. Interesting. It's not really a diagonal, but in order to make it diagonal, I think I needed to make it here. How's that? Yeah. So you could do something like this as well. Right. Let's control the threshold a little bit more. So it's a mixture of the Bayer matrix and the diagonal dithering. Kind of interesting, I think. And if you lower the quantize, it's more obvious the differences. Yeah, like it. Now you might want to increase more like grayscale values to these in order to use more colors, available colors, like that. Just like the Bayer matrix, but it's up to you how you create it. Okay, so for the dithering, I think I'm okay with I think this is it for the dithering that I wanted to show. Now as an additional stuff, I could show some other like effects, something like glitch effect to this image, and maybe some easy subpixel like effect to this one as an addition. So let me just do that and finish this live after that. Okay, so this is the dithering. Now the glitch effect is pretty simple. You just need to shift the pixels in specific directions, X or Y, or diagonal or anywhere. You just need to control the pixels positions from original to the destination. Okay, so I can do that using the same OpenCL, maybe after I have resampled it. Since the glitch, in order to use a glitch, and if you want to have some glitch effect, you need to have some randomness for sure. And in default, OpenCL doesn't have any random functions, unfortunately. So we need to import some of the function which Houdini prepared for us, which is available by importing those libraries, external libraries, which is available as a default library, but you do need to call an import to actually use it. And the informations for those function is available here. The vfxmentor.com quick tips cop. On the bottom of this page, you see a bunch of functions available for OpenCL by importing a ready-made libraries. This is for the noise functions, and there's one for the randomness, I think. Yeah, this one, random numbers in OpenCL. So you can import this function right here, the library right here on OpenCL. By doing that, you'll be able to now use these random functions. Okay, so if I want to glitch in just in one directions, maybe I can just use this one. If I want to glitch in two directions, maybe I can use this one. But for now, let's just shift it in one direction. So I'm gonna use this single value randomness. Okay, so in order to use this, I need a seed value. So let's say I want to shift the pixels in the right and left directions, the horizontal directions, to make a glitch for this image. So meaning the seed could be a y coordinate of this image, which in this case IY. Okay, so let's create a random value using y coordinate of the image as a seed, and I think this value will give you a value in between 0 to 1, so let's subtract it by 0.5 so that the value is in between negative 0.5 to 0.5. Then I'm going to multiply it by the maximum distance of the pixel shift, let's say 30. Then use this value to actually move the pixel to that direction. Okay, and in order to do that, you actually, what I'm going to do is to sample the textures on the source, the original image, using this value as the moved value. meaning I need to convert this value into a UV so that I can use it right here to sample the actual color that I want. So if the pixels is moving into the right hand direction, then we are looking at this point and we need to sample the image which is right here on the left hand side. Actually, we always need to look for the pixels which we are changing, not the source positions. So let's create a UV. So in order to do that, you need to know the current UV of the current pixels, which we've done already last time, similar to what we done before. So ix plus 0.5 divided by x res. That's the x UV. For the y UV, I mean for the v value, iy plus 0.5 divided by y res. Okay. Sorry. And that's the original UV positions. I'm getting an error here. Now, next thing I want to do is to sample the color from the source using this UV. So, float for color sample texture UV. Maybe the spell is something wrong. Texture sample, okay. Texture sample. And replace this destination color with this color that I get. Now, currently the UV is at the same point as the current position, so nothing has been changed. Now it's time to use this random values to shift this X value. And now everything has been shifted. Now it's a bit too noisy here, so let's just choose random number of rows is going to be shifted. So I'm gonna create another randomness using the same function here, but with a different seed. Oh, wait a minute, my keyboard is not working anymore. I think I did something wrong with the input. Okay. Okay. Okay, my keyboard is kind of a dead. Huh. Okay. Oop. Whoa. What's happening? Oops. What is happening here? Huh. What? Okay. It's weird. Nope. Okay, finally. Sorry for that. So, what was I trying to do? So I need to have additional randomness using different seed. Let's change this value as well. Okay, and I want to use this as a conditions when to shift or not. So let's say if random2 is less than 0.2, I'm gonna multiply by 30, else multiply by 0, meaning don't shift it. Okay, now looks more like glitchy effect. Now maybe after this I might want to animate this so that it'll be more like a video-like effect. So I need to do that. I need to use time-based value for the seed. So going to options, let's check include time and then add time information to the random2 seed. Okay, so it's moving. Now let's multiply this by some higher value to make it faster. Okay, can go 20. And that's pretty much it. Let's go to 10. That's one way to create a glitchy effect. It's really easy. And you can now connect it here to be able to use or together with the dithering. It's pretty noisy here. Alright. So that's one thing. That's one effect you could create. Now let's try another one. I was trying to create this subpixel effect, more like mimicking the display, digital display, how the digital display is made. So if you really look closer into the display, if you have a magnify glass to look into the displays, you see 3 colors being used for each pixels to show the colors are red, green and blue. The amount of brightness for each colors, red, green and blue, will be used to mix those 3 colors into to create the actual rich colors like yellow, orange, something like that. So the things that I tried is to kind of mimic these 3 pixels, 3 color pixels to collect a single, represent this single color from the original image to be divided into 3 colors, are green, red, green and blue, and show it as an image just like a display image. That's what I tried, and it's not that hard to do. You just need to create a bunch of red, green and blue arrays as an image and just multiply that with the original color, and there you go, you get the information, you get the result you want as a pixel, as a result. So to do that, first thing first, you need to create a bunch of RGB pixels arrayed in some sorts, and each display has different types of arrays, but in this case I'm just going to create some simple red, green and blue arrays using OpenCL just to test. Okay, so as a base information, I'm going to refer to this one. Why am I getting error here? Oh. Okay, and things that I want to do is to actually, I'm not referring to any color information from the source, but I'm just referring to the size of this image. So based on this size, I'm going to create an array of red, green and blue pixels or arrays. So let's do that. Okay. So I'm going to create red, green and blue separately because it's easier to see. So the things that I want to create is something like this. So R, G, B, okay, and next 3 pixels will become again R, G, B, and again RGB. Or maybe I can include, I can have a black pixels as well. Indicating some space between those LEDs. So R, G, B, something like that. Okay. And I could do this forever for the horizontal directions. Now for the vertical directions, there's 2 choices I can do. One is just shifting the RGB as it is downward, or I could shift the pixels like this so that it looks like a brick wall. I'm gonna go with this directions to create an array. It's more of I don't know, pixel calculations, simple pixel calculations where to put your image. Okay, so for the R, you might want to get the x directions, x index, and then calculate the modulus by 4, since we have 4 different pixel colors, RGB and black. Okay. And I want to check if this is equal to 0. If it is equal to 0, then that means this will become 1. Okay. Now do the same for the green and blue, but instead of using 0 as a result, let's make it 1 and 2. Okay, so if the remains divided by 4 is equal to 1, it's always green. If it's 0, always red. If it's 2, always blue. Let's check the result. Okay, so float 4 R G B 1. Okay, so I can see this tricolor colored RGB on vertically being placed, so that's good. Now next I want to shift this for each I value here. So I mean y value here. So based on the y, either odd number or even number, I want to shift it. Okay, so to do that, I could probably add IY like this one here. This will, I think this will shift 1 pixels for each rows. Oops. What did I do wrong? Use of undeclared identifier IY. Okay, shouldn't use I. It's not a vex, it's an OpenCL. Okay, so it's been shifted, but shifting by 1 pixel doesn't make sense, but you have to shift it by 2 or 3, maybe 3 or 2. So I'll multiply by 2 here, and there you go. Now thing is, it's a bit too close to each other, the pixels, so maybe I might want to have some gap between the first rows and second row. So make the even number all black might make sense. Something like that. So you have a space here, so you have a gap here. Okay, so in that case, I could probably say 3. No. If it's equal to 2, then let me just delete this. I could multiply what I have just written. So if it's an even number, just make it 0. That's what it means. Huh. Why I'm getting these red values? It's interesting. Something must be wrong with the... Okay, alright. This should not come here. But, I see. Okay, so this should goes to here. Okay. Now starting to look like it. Now it's time we need to shift these pixels based on its positions. Okay. So in order to shift it, what I could do, I could just probably add an IY to these X. There you go. Alright. So this is it. So this is the simplified version of Subpixel. I mean, inspired by how LEDs been placed in the display. Maybe normally it's not placed diagonally like this, but it's fine for now. And now since each one of the color are green, red, green and blue has 1 in its channel, if you multiply this value with the original image, you could filter out each pixels, each red, green and blue. You can control the brightness of each red, green and blue channel. So if you look closer to it, it's just the difference brightness of red and green and blue. But if you look from the farther directions, you start to see some rich colors. And that's kind of how display works. And now I realize the channel is being multiplied as well. I mean the alpha channel is being multiplied as well. Alpha channel should be equal to 1. So because is it? Maybe not. Maybe the alpha channel is not really being trimmed. Let me make the background dark. Yeah. It looks fine. Well, since it has a black gap, it looks a bit darker. So in order to make it look more like a display, might want to increase the emission to this. In this case, I can multiply the constant, increase some brightness of this image, like that. And that's how you could do it. If I turn off the glitch, it's like these. It's interesting that I see some colorful informations here. If you look closer to it, it looks like these. It's just a bunch of collection of red, green and blue. Yep. If you increase the size, start to look like a real image. I mean, doesn't really look like an RG or blue, red, green or blue anymore, but if you get close to it, it still is. Yeah, so yeah, I think it's interesting. So by controlling how these like LEDs in being arrayed, you can have kind of a customized like subpixel image, which could be really interesting. And you could tweak these values here. Let's say let's say multiplying IY by 0.5. No, I cannot use float for this one. So if I have like this, it looks like this, right? It's more like a vertical LCD like image. Interesting. You could also make these RGB vertical to make it more like a horizontal scan lined image as well, which could also be interesting. Shall we try that? So in order to make it a vertical, let's create a conditions. If might want some parameters. Shall we create some parameter here? Boolean, no, integer. How do I say? Vertical. Okay, and bind it. Bind parm. What's the name? Vertical. Is this the right way to say it? Forgot. Yep. Bind param name. Yep. Okay. So I had vertical is an integer, and if vertical is equal to 1, use the different RGB, otherwise use this one. So if you want to have a vertical like step, you just need to replace R IX with IY. So in this case you can just say like that. What am I getting wrong? Okay, it needs to be, the variable has to be declared previously. Okay, so let's change this vertical value and see what happens. Okay. And let's also control this shift value by adding one additional parameters to this one. Shift. So let's make this integer as well. 0 or 1. Doesn't have a boolean, right? Nope. Unfortunately, nope. So bind arm shift integer. Then I can create a value called shift is equal to shift equal to 0, and if it's equal to 0, use 1, otherwise 2. And then I'm gonna multiply this to right here. Not here, but multiply here. And if it's horizontal, here. Okay. I am missing semicolon somewhere. Am I? Where is it? Okay. Like that. Okay. So bindings, changing this shift. Okay. There we go. And using vertical image, I think you'll be able to see a horizontally scanned lined like image, which you see a lot in LCD displays. And you could also shift it vertically or horizontally. Yeah. There you go. Okay, I'm not sure if anybody's still here, but okay. Have you ever tried RenderMan shading language? I think you have a lot of fun. Nope, I haven't tried that one yet. I haven't used RenderMan as a renderer myself, but sounds really fun. Yep. Have a good night. It's around 3:20. Well, sorry for that. It's also 3:20 a.m. in Japan. Thank you for joining this late. I had a lot of hassles in the first 2 hours because of the recursive calculations, but in the end it works. Poland. Nice. So it's like 12 hours difference. Interesting. Oh, I see. So it's 8 p.m. there. Yeah, it's 3:20 a.m. here. and I have to go to the place in 9 a.m. today, so I gotta sleep, I think. Okay, well, this is pretty much it for today. So I have tried dithering, glitching, and in the end, subpixels. So hopefully somebody might found this interesting, like I did. And as always, I'm going to upload this file into GitHub. You can download it. I'm gonna post the link to the video description page so that you can test it out yourself. Okay, so thank you for joining. I am going to end this live now, and yeah, as soon as I finish the live, I'm going to upload the files. Yeah. So thank you and good night. Good night to you all. I'm probably it's interesting. So there is tons of parameters that I can change here, but maybe I'm gonna leave it as it is and leave it to you to change these parameters by yourself. Okay, that's it. Thank you for joining and good night. Good night.